All right, here we go with the first video notes of topic 2, which talks about linear equations. In this topic, we're going to be talking about different ways to represent linear equations, such as slope-intercept form, point-slope form, and standard form, and we'll also be talking about parallel and perpendicular lines. Before we talk about any of that, we first have to talk about slope. So today's notes are going to be slope as a rate of change. Slope is how one variable is changing compared to another variable. If we take a look at this graph over here, we can analyze the slope of this graph or the steepness of this graph to show the change in height over time. Okay, the change in height over time. So how the height is changing per unit time is our slope or our rate of change. Using the designated units, we have changing meters per second. Okay, so our rate of change here is going to be meters per second. That's going to be determined by the slope of this line. Rate of change, just in general, how something is changing with respect to another variable, has real-world applications, and they have units. We represent the slope using the variable m. We measure the steepness of a line by comparing the vertical change to the horizontal change between the same 2 points. So if we're looking at 2 points, we can determine the slope or the steepness or the rate of change by analyzing the difference between the vertical change and the horizontal change, right to left. Ways that we're going to represent this in today's notes are m, so m for slope. Graphically, we can see it as rise over run, so that's the change in the vertical over the change in the horizontal, rise over run. Change in y over change in x. Delta y over delta x. So delta is the capital Greek letter that stands for change in. So these are pretty similar meaning. Change in y over change in x. Or we can take the difference, y2 minus y1 over x2 minus x1. So this is the difference in the y coordinates over the difference in the x coordinates. So graphically, let's take a look at this. To find the slope between points A and B, we're going to find the rise over run. So we find the vertical change over the horizontal change. So just looking at this briefly, we see that the vertical change is up 3. The horizontal change is right 2. So our slope would be 3 over 2, rise over run. All right, let's try a few examples. This first one, we want to determine which ski hill is the steepest, A, B, or C. So using what we know, let's use rise over run, or the change in y over change in x. Well, ski hill A has a vertical change of 60 meters. That's our vertical change. So 60 meters over our horizontal change, 70. Well, we can factor out 10 from both the numerator and denominator, so we get that this is 6/7. And approximating this, we get about 0.86. Okay, so the slope of ski hill A is about 0.86. For ski hill B, let's take the change in y over change in x, or the rise over run. So the vertical change is 60 over our horizontal change, 110. Again, we can factor out 10 from both the numerator and denominator. We get 6/11. We can approximate that to about 0.55. So the slope of ski hill B is about 0.55. Go ahead and pause the video and find the slope of ski hill C. All right, go ahead and check your work. Again, it's rise over run, change in vertical over change in horizontal. So we have 80 over 100, which reduces to 8/10, which is exactly 0.8. Now, which one is the steepest? The one that is the steepest is that has the greatest slope. So we look at the magnitude of each of the slopes. We see that ski hill A has the greatest magnitude at 0.86. So let's go ahead and write that out. Ski hill A has the steepest slope. All right, ski hill A has the steepest slope. Let's go ahead and find the slope using a table of values or finding it numerically. So here I have a table of values. We've got the set of ordered pairs, 2, 11, 4, 17, and so on. So let's go ahead and find the slope. Let's use our formula that we can find up here. y2 minus y1 over x2 minus x1. We can use this formula as long as we denote 2 points as x1, y1 and x2, y2. So let's go ahead and choose our first 2 points, 2, 11 and 4, 17. As an ordered pair, we have 2, 11 and 4, 17. So let's go ahead and call that first point x1, y1, and we'll call our second point x2, y2. So to find our slope, m, we can just plug it into our formula. y2 minus y1 over x2 minus x1. So y2 is 17 minus y1, which is 11, over x2, which is 4, minus x1, which is 2. Evaluating the numerator, we have 17 minus 11, we get 6. And the denominator, 4 minus 2, we get 2. 6 over 2, we get 3. So our slope in this case is 3. All right. Another way we could find this from the table of values is just seeing the rate of change. So how do the y's change each time, and how do the x's change each time? Well, we notice to get from 11 to 17, we add 6. To get from 17 to 23, we add 6. From 23 to 29, we add 6. From 29 to 35, we add 6. So every time our change in y is positive 6 or plus 6. Our change in x, from 2 to 4, we add 2. From 4 to 6, we add 2. 6 to 8, we add 2. And 8 to 10, we add 2. So our change in x every time is to add 2. Well, we know that the slope is change in y over change in x. So we have delta y over delta x, change in y over change in x. Our change in y is positive 6. Change in x is positive 2. And again, that reduces to positive 3. So we get the same answer either way. Either of these methods are fine. All right, let's get some practice. Go ahead and flip the page. Okay, so now I want to find the slope given a graph or 2 points. So let's take a look at line segment AB. So we're looking at this segment here. I want to find the slope graphically, so the vertical change over the horizontal change. Well, to go from point A to point B, we have to move 1, 2, 3, 4 units to the right and 1, 2, 3 units up. Okay, let's go ahead and write that. 4 units right and 3 units up. So then our vertical change, that's our 3 units up, over our horizontal change, 4 units to the right. Well, we know that up is the positive y direction, so this is going to tell us a positive 3. And we know right is the positive x direction, so that's going to be a positive 4. So our slope is 3/4. To find it numerically or algebraically, we can find the coordinates for each of these points and use our slope formula. So point A is at the point 2, 4. And point B is at x coordinate 6, y coordinate 7. So we have the coordinates 6, 7. So let's use our formula. M equals y2 minus y1 over x2 minus x1. Well, y2 is going to be our 7 minus y1 is our 4 over x2 is 6 minus x1 is 2. 7 minus 4 gives us 3. 6 minus 2 gives us 4. We can't reduce that fraction, so that is our final slope, 3/4. And notice we get the same thing, graphically and algebraically. Let's try another. Let's try CD. So for C, D, we want to go from C to D. So graphically, the change in y, we have to go down 1, 2, 3, 4, 5. So we go down 5. And then we have to go right 1, 2, 3, 4. So you go 4 to the right. So 5 down, well, down is the negative y direction, so that tells us we have a negative 5. Right 4 is the positive x direction, so that tells us positive 4. So our slope is negative 5/4. Numerically, we can find the coordinates. C is at the point 1, 2, and D is at the point 5, negative 3. Using our slope formula, we have y2, negative 3, minus y1, 2, over x2, 5, minus x1, 1. We have negative 3 minus 2 is negative 5. 5 minus 1 is positive 4. And we get the same slope, negative 5/4. We got two more. Let's try line segment EF. So EF is down here. We've got our vertical change over our horizontal change. Well, notice from E to F, we don't have to move up or down at all. There is no vertical change. So we can say that the vertical change is 0. Over the horizontal change, well, to go from E to F, we just go right 1, 2, 3. All right. Well, right is the positive x direction, so we have 0 over positive 3. Well, 0 over positive 3, that's just 0. All right, let's find it using our points. So we have E is at the point negative 2, negative 3. And we have F is at the point 1, negative 3. So we find y2 minus y1 over x2 minus x1. y2 is negative 3 minus y1 is negative 3. And watch those negatives there. We have minus a negative over x2, which is 1, minus x1, which is negative 2. Again, that double negative. So we have negative 3 minus negative 3 gives us 0. 1 minus negative 2 is positive 3. And again, 0 over 3 gives us 0. All right. We got one more here. So GH, well, the vertical change to go from G to H, we go up 1, 2, 3, 4, 5, 6, 7, 8. So we go up 8. And we don't go right or left at all. It's just up. So we can say that the horizontal change is 0. Well, up is the positive y direction, so we have 8 over 0. Well, 8 over 0, we can't divide by 0. 8 divided by 0, we can't do that. So we would say that anytime our denominator is 0, that this is undefined. We cannot divide by 0. Undefined. So line segment GH has an undefined slope. And we can show this numerically by finding the 2 points that G and H are at and using our formula. So G is at the point 8, negative 3. And H is at the point 8, 5. So y2 minus y1, we have 5 minus negative 3 over x2 minus x1, 8 minus 8. 5 minus negative 3 gives me positive 8. 8 minus 8 gives me 0. And again, we have 8 divided by 0. We cannot divide by 0. So that's again an undefined slope. Okay? Last thing I want to talk about today are the slopes of horizontal and vertical lines. Let's first take a look at this one here. We've got the line here, and I'm just going to outline it in red just so that it's a little bit easier to see. We've got this line here, horizontal line. Let's pick 2 points on this line here and find the slope. So let's choose this point here, and we'll choose this point here. So those points are 0, 4. That's on the y-axis. And we have 2, 4. Well, let's go ahead and find the slope. So let's label these x1, y1, x2, y2. So plugging it into our formula, m equals y2 minus y1 over x2 minus x1. We get 4 minus 4 over 2 minus 0. Well, 4 minus 4 is 0. 2 minus 0 is 2. 0 over 2 is 0. So the slope of this horizontal line is 0. And in fact, that's true for all horizontal lines. So let's go ahead and write that out. Horizontal lines have a slope of 0. Horizontal lines have a slope of 0. That's true for all horizontal lines. They all have a slope of 0. Let's take a look at vertical lines. So again, I'm just going to outline this in red so that we can see. Let's choose 2 points. So let's say we'll choose this point here, and we'll choose, say, this point here. So we have the points 2, 0, and we have the points, say, 2, 3. You can choose any 2 points in the line. And again, x1, y1, and x2, y2. All right, so using our formula, m equals y2 minus y1, we have 3 minus 0 over x2 minus x1, we have 2 minus 2. Well, 3 minus 0 is 3, and 2 minus 2 is 0. Uh-oh, we've got 3 divided by 0. Can't have that. Cannot divide by 0, so this has undefined slope. All right, and in fact, that's true for all vertical lines. Let's go ahead and write that out. Vertical lines have an undefined slope. That's true for all vertical lines. Vertical lines have an undefined slope. All right. So today we've talked about finding slope, rise over run, change in y over change in x, y2 minus y1 over x2 minus x1. We found different ways to represent the slope, and we understand slope as a rate of change. All right, we're going to get a whole lot of practice on this in class, so we'll see you tomorrow. Have a great day, everyone.